All right, last problem, number 6. Very last one on homework 5 in unit 2 of geometry. So this is another angle proof. So let's go through each statement and see what allows us to, which of these rules or definitions or properties or theorem allows us to say each one. So angle 1 and 2 are complementary and angle 3 and 4 are complementary. Notice what allows us to say that. It was given. So both of those are given. Both of those are given. So 1 and 2 are both given. Since they were given to us. So 1 and 2 are both given. Okay, number 3. So what allows us to say that if angle 1 and angle 2 are complementary, what allows us, which of these rules up here allows us to say that the measure of angle 1 plus measure of angle 2 equals 90? So, if you remember, so these are complementary. Which of these has to do with complementary angles? Probably the definitions, right? And yes, you are right. The definition of complementary angles allows you to say that if angle 1 and angle 2 are complementary, then their sum is 90. So, number 3, Number 3 is going to be definition of complementary angles. And look at number 4. Number 4 is kind of the same thing as 3, but it just used angle 3 and angle 4 instead of angles 1 and angle 2. So that one is also going to be definition of complementary angles, because that's the conclusion of that definition, given a hypothesis of two angles being complementary. So both 3 and 4 are definition of complementary angles. Now, number 5. Angle 2 is congruent to angle 3. What possibly could allow us to say that? Where are angle 2 and angle 3? We haven't even mentioned them in the givens up here, but notice. What do we know about angle 2 and angle 3? Well, angle 2 and angle 3 are vertical angles. We know they're congruent because they're vertical angles. And we know that's the conclusion of the vertical angles theorem. If angles are vertical, then they are congruent. So angle 2 is congruent to angle 3 by the vertical angles theorem. Notice, all we needed was the picture to be able to identify those angles as vertical, right? We didn't have to be told that angles 2 and angle 3 are vertical. The picture here, the figure, was enough justification to say, yes, they are congruent by the vertical angles theorem. So number 5, vertical angles theorem. Number 6. Measure of angle 2 equals the measure of angle 3. So we went angle 2 is congruent to angle 3 to their measures are equal to each other. Hopefully you remember off the top of your head, but if not, remember the definition of congruence is what allows us to go back and forth between congruent signs and equal signs, as long as you're dealing with these same angles. So it's the definition of congruence for number 6 that allows us to conclude that measure of angle 2 is congruent to measure of angle 3. All right, now for number 7. Okay. Measure of angle 1 plus measure of angle 2 is equal to measure of angle 3 plus measure of angle 4. Where did that come from? Well, Okay, so what I'm looking back up here is what, out of all these put together, what can we possibly be looking at that allows us to say that measure angle 1 plus measure angle 2 equals measure angle 3 plus measure angle 4? And what I see is that both of these, measure angle 1 plus measure angle 2 equals 90, and the measure of angle 3 plus measure angle 4 equals 90. If two separate things are both equal to 90, then we can say that they're equal to each other by the transitive property. So that is the transitive property that allows us to say that. Transitive property right there. And remember, make sure you're marking these out as you go, so you're able to use process of elimination as well. Okay, so notice what happens between step 7 and step 8. Let's look at the left side of the equation and see what's stayed the same and what's changed. We still have measure angle 1 in both spots, but measure angle 2 became measure angle 3. And then on the right side of the equation, measure angle 3 stayed the same and measure angle 4 stayed the same. So it seems like measure angle 2 was replaced by measure angle 3, probably by the substitution property. And Remember, we just said that they were equal. So yes, it was substitution property that allowed us to replace the measure angle 2 with measure angle 3 and rewrite our new equation here. So that was the substitution property. So once we have 8 here, what possibly happened that gets us to 9? Well, if we look at this equation, measure angle 1's still there, measure angle 3 disappeared, and then on the right side of the equation, measure angle 4 is still there, but measure angle 3 disappeared. What could we possibly do to both sides of the equation to make that happen? Well, we subtract the measure of angle 3 from both sides. So that would be subtraction property that gets us to number 9. And then finally, what brings us from equals back to congruent? Definition of congruence. Definition of congruence. That concludes homework 5. Good luck studying, everyone.